So homework 6.3, number 3, we're asked to evaluate the inverse tangent, and the answer should be in radians and in the interval -pi/2 to pi/2. Now that's a good interval because that's the natural range of the arctangent, which is what we have here. And we're going to end up with pi's involved there. So I just want to think about the unit circle for a moment. So on the unit circle, we have a couple ways to think about the tangent and the arctangent. So radius of 1 and the tangent of an angle could be either thought of as the slope of the radius, which is the y value over the x value of any particular point. And then we have our special angles of pi/6, pi/4, pi/3, pi/2, and 0 down here. And the slopes of these y over x, so here I would have a slope of 0 because the y value is 0 and the x value is 1. So here I get a slope of 0. Sorry, it's down lower. Down here, m is 0. Over here, I have an x value of √3/2, a y value of 1/2, and that simplifies to a slope of 1 over the √3. Here at pi/4, x and y are the same, so slope is 1. Here we switch the x and y from this point over here. We're going to get y is √3/2 over 1/2. That slope simplifies to the √3. And slope over here would be y over x, 1 over 0. That would be undefined. So those are the special angle slopes. And if we were in the quadrant down here, we would just get all of those but negative. So we have negative slopes down here. So tangent inverse of 0 radians has a slope of 0. Tangent inverse of the √3/3, well, that doesn't match any of mine here. But if I think about this one right here, 1 over the √3, if we rationalize that denominator, multiply top and bottom by the √3, 1 times the √3 is the √3. √3 times the √3 is 3. Aha, this one right here is pi/6 for the angle in radians, and a slope of √3 would be pi/3. So very important that you know special angles in the first quadrant, and then you can relate those to other quadrants. And knowing that allows me to solve these exactly.